Okay, so in the next video, we are going to start with the annual compounding calculations, and the rest of this presentation file, as previously said, is very important for your future engineering economics studies. So please study this next part very carefully until the following week. First, we are going to start with the single payment analysis, but this is simply going to be a repetition of what we have done in the last week, but this is just going to be a passage for us to the next part where we study the uniform series analysis. So single payment analysis deals with what we have done so far. We are trying to finding the future worth for a principal amount, or vice versa, we can find the present worth of a future single payment. But this time, using formulas that we have previously learned, actually they were very simple formulas, but this time we are going to use compound interest factors, and for that, we will use compound interest tables to identify these factors. So at this point, let's talk about the single payment compound amount factor. And imagine now, we have a principal amount today, right now, and we are saving this or investing this principal amount into a savings account that gains interest at a rate of I% per year, which compounds annually. And that money is going to be converted into a future worth of F in the end of n years. And in the end of n years, we are going to withdraw this money. Okay. Now, how would you calculate the future value from your principal? You should know it is equal to P times 1 plus I to the power n. In other words, the ratio between the future value and the present value is going to be 1 plus I to the power n. So that ratio, the ratio of the future value, single future value and single present value, is called the single payment compound amount factor. Compound amount factor because it is converting the today invested amount to the compounded future amount. Okay? And that formulation, 1 plus I to the power n, can be different for every different interest rate and every number of investment years. Therefore, we will use an extended notation to represent that compound amount factor, and we will say that the F over P ratio, or in other words, single payment compound amount factor under I% interest rates per year and for n years is calculated as 1 plus I to the power n. Now, this value can easily be calculated by calculator. However, this value can also be searched through a compound interest table, which already has stored many calculated compound amount factors. Now, as we solve this next question, we are going to see how we can utilize the compound interest factor tables which are already uploaded in the Blackboard environment. You can take a print of this compound interest factor tables before the exam, so you can use them, use a clear printout of them through the exam as well. A student deposits $1,000 in the account that pays interest at the rate of 6% per year, compounded annually, it says. Okay, so we have $1,000 in a savings account right now, and that savings account pays interest at a rate of 6% per year. So my I, the interest rate is 6%, and my principal amount is $1,000. If all of the money is allowed to accumulate, which means through the investment period, the student is not going to withdraw any amount of money, how much money will the student have after 12 years, it says. So the total investment years, number of investment years is 12. So here, the given information, the question can be summarized as P to be equal to $1,000, the principal amount. The annual interest rate is 0.06 as decimal, and the total number investment years is 12. So what we are going to do is to calculate the total accumulated amount in the end of 12 years. And that is going to be 1000 times the principal times F over P under I% interest rate for n years. So this is the extended notation for the compound amount factor. So first you need to formulate your equation like this. So what I need to do is I need to multiply my principal with single payment compound amount factor, which is the F over P factor under I% interest rate for n years. Then you can plug in the values and say, I need to multiply 1000 with the single payment compound amount factor under I% interest rate for 12 years. Now, what you can do is you can either calculate that value according to this formulation, 1 plus I to the power, or we are going to search through a compound factor table, compound interest table. Now, I'm just going to change my screen share to my whole desktop. Okay, now you can see my whole desktop. And I'm just going to show you this folder, and a similar folder is available for you in the Blackboard. Here we have our first table. The name of the table is the annual compounding table, compound interest factors, annual compounding table. Now, if you open this file, as you can see, we will see pages of tables. If you just scroll down, you will see pages of tables, and each page corresponds to a certain interest rate. So we start from 0.25%, or in the decimal format, it is 0.0025. And in the next page, we have 0.50%, or as decimal 0.05. And in the next page, the interest rates are going to increase and increase. So we have 1, 2, 3, 4, 5%, 6%, 7%, 8%, 9, and 10. After 10%, we jump to 20%. So there is not a page for 11%. There is not a page for 13 and 14%, only 15. And the next page gives me 20% interest rates. Okay, so we have compound interest factors for different interest rates like this. And in the first column of every page, you see single payment compound amount factors. So remember, in our problem, we would be interested in a 12-year single payment compound amount factor under 6% interest rate. So what I need to do is I need to identify my page for 6% interest rate, and for 12 years, as you can see, my single payment compound amount factor is 2.0122. Now you may think at this point, if we had used a calculator, it would be much more faster because the formula was so simple, but there will be reasons why we are using this table in the future. So we are going to explain this later. Okay, so at this point, I'm just teaching you how to use these tables. For this simple question, obviously, it would be much faster to use the calculator. However, will be times that we will only solve the questions by using these tables, and calculators wouldn't be very easy to use. Okay, so my single payment compound amount factor is 2.0122. Now, in fact, you can simply, so if I write calculator here, you can simply calculate that value as, so let me change to the scientific version of my calculator here. Okay, so I write 1 plus 0.06, I close my parentheses, and now I am just going to take the power of this value to the power. What I'm going to say is 12 years, right? 12. that would be equal to 2.012 approximately again. And there is also the rest of the value. As you can see, after the decimal point, we can see too many integers as here. So we are just going to use the approximate value of 2.0122, and that would make our $1,000 that is invested today equal to $2,012.20. Okay, so that would be the approximate amount of money that would be accumulated in the savings account. Now we can also do the same type of operations in the reversed order. Okay, and we call this the single payment present worth factor this time. In this case, if we have the future value of the money, if you want to calculate the present value of it, then you need to multiply the future value with single payment present worth factor. That is the ratio between P and F. Okay, so P and F, P over F. So that converts the F value. If you multiply F with P over F, F will cancel out, and what you are going to see would be P. So P over F is the factor that converts the future value into the present worth or the principal amount, and that is formulated as the reciprocal or the multiplicative inverse of the single payment compound amount factor. That would be 1 plus I to the power minus n. Okay, so if you use the extended notation for P over F, you can easily construct this equation P over F under I% interest rate for n years, or in other words, single payment present worth factor under I% interest rate for n years is equal to the multiplicative inverse or 1 over F over P under I% interest rate for n years. And remember, F over P is the compound amount factor. Now, due to this construction, even though we do not have any column that's showing us P over F values in the compound factor table, interest tables, you can simply calculate that value by first checking the F over P, the single payment compound amount factor from the table, and take the multiplicative inverse of it. So, or you can use 1 plus I to the power minus n as a calculation. Now, let's solve another question. A certain sum of money will be deposited in a savings account that pays interest at the rate of 6% per year, compounded annually. If all of the money is allowed to accumulate, how much must be deposited initially so that $5,000 will have accumulated after 10 years, it says. So the interest rate that we are being exposed to in this question is 6%, okay? And what we need to deposit right now is unknown, but our objective is to collect $5,000 in the end of 10 years. So this time, the future value is given as $5,000. The interest rate of the savings account is 0.06 as decimal, and the number of investment years is 10. Now, the present value of this money, it can be calculated by multiplying the future value with single payment present worth factor. And that is $5,000 times the present worth factor, P over F, under 6% interest rate for 10 years. Now, how am I going to find this value? I can either use my calculator once again. So what I can do is to open a calculator here, and I can do what? I can write, what is my interest rate? 6%, 10 years, right? So 1.06 parenthesis to the power minus 10. So I will write, I'm sorry for that. So let me start from scratch. Okay. So I have 1.06 here. I will say to the power. Okay. So let's calculate everything and clear. Okay, now everything is clear. 1.06 to the power, we say minus And okay, that is problem. So let's do it another way. Okay, I really do not know how to use the calculator of Windows. So what I'm going to do is 1 over parenthesis 1.06 to the power 10. Now that is better. Okay, so 0.5584 approximately. This is exactly what you see as the value here. Okay. Now, what you learned from this experience is what you need to know how to use your calculator. Okay, so this is your responsibility. During the exams, it is impossible for me to teach you how to use the calculators because they are of different brands, as you see. So you need to know how to use your calculators. Okay, so we have P over calculated as 0.558384 approximately. However, we can also calculate this value from our table. Now, let me show the compound factor tables once again. This time, we are looking at 6% interest rate. However, for 10 years, we have the single payment compound amount factor as 1.7908. Okay, but this is the compound amount factor. What we are interested in is the reciprocal of this, multiplicative inverse of this, P over F. So what I am going to do is, again, I am going to use my calculator, and I will simply say 1 over 1.7908. And that is again 0.5584 approximately. Okay. So this is how I can use these tables, and I can calculate 1.7908 from the compound amount factor table as the compound amount factor for single payments, the multiplicative inverse of it, what we are uses an equation for the present worth factor, and that makes 2,792. So this means what? If you invest $2,792 right now into your savings account that pays 6% interest rate per annually compounding interest rates, and that is going to become $5,000 in 10 years. All right. So in the next video, we are going to study the uniform